So I know it isn't clear yet how we get here, but is it clear what we're trying to achieve? Right? That when you create that inner procedure, the one that's highlighted up there, it remembers where to find the value of result. Right? That's the goal. And if we can do that, then we can have different counters that each have their own result. So far, we don't. So far, we only have one counter because we're working up to this a step at a time. But we want to see how this kind of expression turns into the count procedure, which is just that highlighted stuff, except knowing which version of result to use. So if we had a lot of these counters, if we said define count 2 and then the same thing, in fact, that might be worth doing. Never thought of that before. Let's define count 2 to be all this. Oops. Copy. Paste. Okay? So now we still have count, and it's now up to 4. We also have count 2 that's starting at 1. Here's the original count up to 5. Okay, so we have two counters, each of which has sort of the same code, but two different result variables. Right? Because we did that let twice, one when defining count, and then again when defining count 2. Okay? If you're feeling iffy about this, it's not surprising. Stick with us. The thing we're doing right now about what it is that we're trying to achieve. Namely, how can we get persistent local state variables? All right. Let me actually, I'm going to write that down. Persistent local state variables. Okay, you know what a variable is. So what's special is that we want two things that used to be contradictory. We want persistent and we want local. Global variables have always been persistent. You define it, it's there forever. Local variables until now, well, until last week, I guess, have always been kind of ephemeral. They come into being when you run a procedure, and they disappear again as soon as that procedure finishes. So we want something that is like the best of both worlds. It has the sort of cleanliness advantage of locality, so that it's restricted to a particular piece of code, and the persistence of global variables. And we now see how to achieve that with the lambda inside the let. But what we don't yet know is how that works, how that manages to make a persistent local variable. And that's what we're going to see the rest of this week. Or you are without me. OK. Now what we're going to do is we have how to make a single counter. And now we're going to look at how to implement essentially a class. So I have this thing make count. Make count is sort of the equivalent to define class count, although it's much simpler than what a defined class turns into. So every time we call make count, it's going to make a counter. And notice that there are parentheses around make count. So the let that you see up at the top of the screen is part of the body of make count. It's inside the make count procedure. So it works like this. Define C1 to be, oops, make count. define C2 to be make count. And now I just call C1 okay, that's one counter. And now I can call C2. It starts from 1, counts up. Now if I go back to C1, it'll say 5. Okay, so C1 and C2 are two counters. Make count is sort of a counter factory. And the way make count works is that every time you call make count, it does this thing about a lambda inside a let. So the value that make count returns is the value of this innermost lambda expression. So each counter is a procedure created by this lambda expression. But I can't any longer say, is this procedure? Because now we know that a procedure isn't just the information in the lambda expression, namely the formal parameters in the body. It's also what we're going to call an environment, meaning what are all the variables outside of this procedure to which this procedure has access? So how do we resolve free references, that is, references to variable names that aren't formal parameters of the lambda? And the answer is we look them up in the environment. And the environment gives us the value. Actually, technically, if you're a programming language person, I'm not supposed to say the environment contains the value. What I'm supposed to say is that the environment binds the name to a box, and you can change what's in the box as a 0 or a 1 or a 2 or whatever. But this is a level of complexity that we really don't worry about in this class. It's not going to matter because you're not trying to write a very efficient compiler for language. Okay, so that's make count. If I move up here and come down a bit, this is make count with all the lambdas made explicit. So this lambda comes from the fact that make count was in parentheses when I said define make count. So define with parentheses implies a lambda, and this one has no formal parameters because it was open parenthesis make count, and then there weren't any formal parameter names, just close parenthesis. This lambda comes from the let result be 0. Okay? So notice that this second lambda is the only one that has two open parentheses in front of it. Now, in talking about this, I don't want you to put in your head a sentence that starts, you have to use two open parentheses when blah, blah, blah. Okay? Instead, I would like you to understand what each of these parentheses delimits. So we just happen to be creating a lambda expression, this one. So this open parenthesis, the inner one, ends here. And that whole thing is a lambda expression. So it creates a procedure, namely the let procedure. Right? The outer lambda was make count. The second lambda is the let procedure. And then this open parenthesis goes with the inner lambda expression that I just showed you, and the 0 and this closed parenthesis. Okay? So the outer parenthesis right here, oops, this one, says call this function with the argument 0. Okay? And that's the let. A let is an abbreviation for two things, a lambda expression and an invocation of that procedure. So that's why there are two parentheses here, because the let abbreviates two steps. Make a procedure, invoke it. Okay? This inner lambda doesn't have two parentheses around it. It just has one. And this is the value that the second procedure returns, and therefore it's the value that the first procedure returns. So this inner lambda is a particular counter. It's C1 or C2. Is this inner lambda, or a procedure generated by this inner lambda. Now, the way we get two different counters out of the same piece of code is C1 is this procedure, and C2 is this procedure, and they point to the same lambda expression, but they have two different variables result. Two different environments, each of which has its own result variable. Okay? So, same procedure text, but different procedures with different persistent local state variables. Okay?